Hello, everybody, and welcome to the Reuse Company webinars. Today's topic is getting started with requirements quality assessment. This is the agenda for the webinar. First, an introduction to the company. Then we will see the dangers of poor quality requirements. Next, we will learn how to improve quality. And after that, we will see the digital solutions RQA and RAT. Finally, we will have some time for questions. So, who are we? My name is Cecilia Karlsson, and I work in the Marketing and Communication Department. With me, I have Jose Manuel Pereira from the Commercial Department, and he will show us how to get started with requirements quality assessment. The Reuse Company was created in 1999 as a spin-off from a university in Madrid, Spain, by system and software engineers. Our headquarters is in Madrid, but we also have an office in Stockholm, Sweden, and a delegation in Japan, in Tokyo. In 2021, we are planning to open an office in the US. Our mission is to promote a reusable, scalable, and global solution to a smart and interoperable systems engineering environment. And we do this by offering a semantic, knowledge-centric approach. The Reuse Company is also called TRC. We like to say that it's easy to remember if you think of T like in traceability, R like in reuse, and C or almost Q like in quality. Who is using our technology? Here you can see some of the companies that are users of our system. They come from quite different industries like aerospace and defense, energy, automation, and healthcare, but also from other industries. So let's start then with today's topic. Hello, Jose Manuel.
Hi, Cecilia. Thank you very much for such a great presentation. So yes, as Cecilia explained, today what we will be doing is basically taking a look at the basic concepts regarding quality assessment, specifically focused on the requirements management, right? So the three main topics that we are going to take a look at today are basically the dangers of poor quality requirements, which is the actual impact, or which are the possible scenarios that we will encounter once we have poor quality requirements, how to improve that specific quality in order to avoid those scenarios, and finally, two digital solutions which provide us aid when trying to improve the quality of the requirements, right? So let's jump right into it, and let's begin with the dangers of poor quality requirements. So the first thing I would like to take a look at is history, right? Then we'll take a look at the actual impact of those poor quality requirements. But at the beginning, I would like to present you three main evidences, right? So we're going to take a look at three core questions, which are who, why, and which is the actual impact. For the first one, we're taking a look at NASA, right? NASA had a Mars climate orbiter who had a series of problems. It burned in Martian atmosphere, and it was due to a failure when converting from English to metric system, and it cost a total amount of $125 million, right? So for a metric conversion failure, we have more than $100 million in terms of investment. So with this, we conclude the first evidence. We'll take a look at the second one. We're talking now about SNCF, which was building a series of French trains, and due to a lack of organization and trying to measure the actual stations that were built 30 years ago, they had a problem, and the trains could not feed through those stations. They could not be stationed there. So that led to an amount of 50 million euros additional to the initial ones for the repairs and modification of these trains or stations, right? Once again, conclude the second evidence. Going for the third one, we're now talking about Airbus. And in this case, what basically happened is the engines had liabilities due to lack of precision in some of the requirements, and that led to project delays and billions involved for companies such as Germany. As here you can see the total amount, it was 1.5 billion euros. And when we are talking about billion, we know that this is a serious matter, okay? So these are the three core evidence. I hope they provided you with a little bit of context. This is something that happens even to the top companies. So we have to, of course, look out for each one of these issues, right? Regarding the impact, what we have here is a graph showing how that cost, had that impact, can increment as long as we go through the project development, right? So the first phase is going to be concept. We're not going to have any further impact if we have mistakes. It is the best, without question, the best time to detect those errors. We then proceed with the design phases. Take into consideration that this is very general. We're talking about progressing through the development of the project. Each project is independent and depends on the context and the phases planned at the beginning. But for the sake of the example, we'll take a look at this graph, right? So for the design, we're already having an increment in terms of cost. In this case, it is not too noticeable, but we still have to take into consideration, right? Sorry. We continue with the development. We're now trying to develop the actual elements based upon the requirements, models, so on and so forth. And we could include in this phase the testing, which is, of course, one of the phases where we find most of the defects, and most of the defects are corrected, right? Still, we have, as you can see, an increment in terms of the investment that you have to make in order to correct those errors, right? Once we get into production, we have finalized all the testing, the development itself, and we get into mass producing the system in this case. Then if we find a defect or a problem, as you might notice, the increment in terms of cost is skyrocket, right? And finally, of course, in terms of operation, if a user is actually making use of our system and he or she finds a defect, then it has to trace back to even the very beginning. So the cost is immense, right? So we've seen how this is dangerous, how having poor quality requirements is dangerous. Let's take a look at how to improve that actual quality. Okay, fragmented this section in four core parts, right? The first one is going to be quality characteristics. Then we're going to proceed with quality metrics. This is very important not to confuse both of them. Then we're going to get into some basic tips, guidelines. And finally, let's take a look at a very simplistic approach in terms of patterns, right? We begin with the quality characteristics. We basically abbreviate them as SMART, right? And it means basically specific, measurable, attainable, relevant, and time-based, right? But why do we do this? Let's focus on the SMART part, right? For the specific part, we want the information to be precise. Of course, this is always in general terms, right? Measurable, we need the information that we provide to be measurable, because therefore we will not be able to verify precisely. Once we get to that phase, we would not be able to complete that process, right? If we are not capable of determining the actual length of the progress, or the actual length of a specific requirement information. Attainable, of course, the development must be based on realistic planning and objectives. We cannot try to do things that we are actually not capable of with the resources and materials that we have, right? Then we move on to relevant, because we need to kill the noise around the project. We need to focus on the actual important matters. And finally, time-based. We need to keep track of the time in order not to exceed that resource, or in order to have a considerable amount of time in order to correct or to revise the problems that might arise through the development, right? And as you might have noticed, we have two other ones, the verification and traceability below, and I wanted to add those. Of course, you have plenty of other quality characteristics to be considered, but as this is a basic approach, I would like to only start with these two, which I find are the most important ones among those. Because verification is core, is key, during the development of any system if we do not verify against either standards or from right to left, if you know the B model, from the system against those requirements, models, so on and so forth, then we will have a system which we do not know if it's compliant with everything that we designed it to be, right? And then we have traceability, which of course is once again fundamental, because we need to trace back. We need to be able to link to the top of the hierarchy the different elements that we have developed, right? So from a screw, from a component within the system, we need to trace it back to the actual necessity of why we need that specific component. If not, then we're making a huge mistake and we will have problems later, right? So moving on to the quality metrics. For the quality metrics, basically, we can highlight three of them, which is the CCC, the famous CCC, in this case, correctness, completeness, and consistency. Basically, what we are talking about is the following. For the correctness, we're trying to specify requirements which are, in this case, let's talk about requirements. Those requirements must be compliant with the needs, the standards, and any expected results from the system, okay? For the completeness part, what we want to do is to not miss out on any possible element which might be involved in the fulfillment of those needs, right? So we want the needs to be fulfilled completely, and we want to not miss out any element. This might be components of the system, phases throughout the planning, so on and so forth, right? And for the third one, we're talking about consistency. And in this case, it's basically trying to avoid any kind of contradiction or even unnecessary elements which might lead to development problems, of course, right? So with this, we move on to the 12 basic tips. Notice, keep in mind that these are only guidelines, okay? So this is not the law. You should take into consideration most of these guidelines, but this is only a Kickstarter for you to start improving the quality of your own requirements, right? This always depends on the context of the project and the purpose of each one of the requirements. So for the first one, we're talking about short and precise. And this basically means that we want to get straight to the desired information. Once again, avoid any kind of noise, because it is always easier to understand at one glance a requirement which is short and precise than another one which is very large. Of course, here rises a matter which was commented on the previous session, and it is very interesting because when you're talking about short and precise, precision comes usually in our language with more terms. Okay, usually, of course. Right? So you're trying to be short and you're trying to be precise, and sometimes it is very difficult to maintain that balance between length and accuracy, right? So this is very important. There's no problem on the requirement getting a little bit longer if you need precision, especially when we are talking about system requirements and so on. But this balance is fundamental to have clear requirements, of course. Proceed on to number 2, which is basically shall and must. These basically indicate the strict necessity of our system or any element within it to behave or to function in any specific way, right? And we should always avoid should, might, all those kind of terms which are not conclusive, right? Which are not strictly indicating the action or the behavior or the characteristic that our system must have. Right? So for the third one, atomicity is basically related to the first one, and we could sum it up as tackling one detail at a time, okay? Fourth one, avoid passive voice, okay? This basically simplifies things when trying to read and understanding the information within the requirement. But of course, there are specific scenarios where you could apply this passive voice, right? Conditions, and it always depends on, as I was mentioning previously, the context of your project, right? And the way of writing your requirements. So for the fifth one, avoid negative. This basically is specified because we should try to describe what the system must do, not what it must not do, right? it's always easier to specify the little things or the details, the exact list of things that the system must be compliant with, than all the things that that remain. Okay. Of course, for this case, I have a special example for you to notice that, of course, these are only guidelines, no rules. So for in some cases, I've seen safety requirements, okay, where you usually try to specify what the system must not do. It must not put at risk the lives of the people involved in its usage, right? Or it must not burn anybody because there's a failure, okay? So in those cases, then negative clauses might be your solution, okay? For the sixth one, we have consistent vocabulary. Basically, depending on the topic, we have always consequent terminology and regulations. So it's trying basically to commit with them and avoid issues when describing, right? Issues such as ambiguity, right? Because those terms which might lead to ambiguity could generate noise, confusion, and they require clarification, thus going against the core meaning of clear and precise requirements, right? Because we try to communicate information clearly and in a matter of seconds, well, at least trying to, right? The simplest possible and the clearest possible way. No solution. This basically means that we try to keep all solutions out of a related specification. We specify a requirement. We do not want the consequent solution to a possible issue or a possible problem that might arise, right? Those solutions need to be translated into mainly additional requirements, okay? So, for example, the car must accelerate from 0 to 100 kilometers per hour in X seconds, okay? So this is one clause, and we do not want to add anything else to it, right? This should be something that we move on to the next requirement, and we specify precisely this should be done in the system requirements layer. The engine must have an energy of X, Y, or Z, right? So we have translated from the necessity of the car to be accelerating for 0 to 100 kilometers per hour in X seconds to the actual motive of the system to be capable of doing that, right? Which is basically having an engine which is capable of powering that car or increasing the acceleration in X, Y, or Z. Okay, so this is the idea to not include solutions in requirements. Wise numbers. This is very simple. It is being very careful with the numbers that we utilize, measurement units, and conversions, because as you might have might know and might have seen in the previous examples, sometimes even top companies make mistakes when trying to convert or considering different measurement units. So requirements model consistency. Of course, we want the models to resemble the actual structure, either architectural, behavioral, so on and so forth, which has been defined in the previous requirements. We must be able to trace or to link between the model elements and the requirements that led to them, because if not, as we were mentioning previously in the traceability part, we need those traces to be able to, if there's any issue detected on a component, we need to trace back to the need or to the requirements that led to that component, okay? So for the 11th, the level of detail. This is very important. We have to adjust the level of detail to the phase in which we are, right? So initially in the stakeholder requirements phase, it's usually less level of detail than, of course, in the system requirement specification part. But this is, of course, something that the other day also arose, and it is that precision must always, or detail must always be present, despite the phase that we are into. And that's certainly true. We always have to try to be as precise as possible, even if we are in the first phases, even if we are specifying the needs of the project, right? This is the key to having a full precise specification from the beginning to the end, right? And for the 12th one, the writing style. This is something that relates a lot with what I've been explaining in terms of you have always to be prepared to adjust these guidelines to your own context, to the project context, the conditions, to the way that your company is writing, the way that the client wants you to be writing, and of course, the standards that you follow through, okay? And for the final one, the 13th, and the most important one is common sense. This relates to exactly what I just explained, is to try to make the decisions according to the circumstances in which you are, the company is, and the project is developed, okay? So let's take a brief look at the patterns, right? So this is going to be a brief example. A pattern, as you might know, is basically a structure which provides you with the structural elements in which you can substitute the different, we could say it like that, you can substitute the different components for the corresponding specification, right? So it's basically a backbone, a guideline of how to specify a concrete requirement depending on the topic. Of course, there are patterns for safety requirements, for functional requirements, for so on and so forth, right? So in this case, we'll take a look at a very simple one, which commences or begins with a when plus condition. So the structure part is going to be on top, and then below we have a little example, right? So when plus condition, as you can see, when the temperature warrior, which is our system, our overall system, detects an object in front, let's say like that, then we have a subject plus a shell. In this case, the brake system, which is a subsystem within our overall one, shell. And what does it do? An action plus an object, stop the acceleration engine. And now finally, we add a constraint, okay, in less than 20 milliseconds, right? Let's take a look at another example, and this won't complete from the beginning, right? So same structure, when, condition, subject, right? And this is, of course, this is what I was explaining before. You can substitute the different elements into this structure: shall, action, subject, and finally the constraint. Here you have another example. When the gas pedal, is pressed, the car shall reach 100 kilometers per hour in less than 5 seconds. Okay, so this is basically a pattern. Provides you with the structure of a requirement, and this is very, very useful to not make any mistakes in terms of structural design, right? For those requirements, for those specifications. Depending on the type, you have your pattern, and then you ensure that you're not gonna you're gonna have the most quality possible, or the highest quality possible in terms of structure. So we have concluded which are the problems, or which is the impact of having poor quality requirements. We have proceeded with how to improve them in a basic manner. Of course, notice or take into consideration that this is a basic and initial approach. This can be expanded so much more. And finally, we will take a look at the digital solutions, in this case, a practical example with our tools RQA and RAD. Okay, so for this section, basically, we're gonna show you two main examples, two simple examples. And in those, what we are basically gonna do is write the requirements, specify the requirements. It's gonna be a very simple specification, 4 or 5 requirements. Then we can evaluate two main metrics, which are going to be basically the correctness and the consistency, and we will try to correct those and to improve the quality in line, right? So for the first one, writing requirements with RAD. Okay, so this is going to be the full process. We're going to begin, as always. Imagine that we have our Excel file in which we are going to specify the different requirements for the system that we're trying to develop. Okay, those are the subsystems, and this is the connection process. Okay, so this is our tool. We establish the connection with our Microsoft Excel. This connection is going to be called temperature war, which is our system in our project. System requirements, of course. And now, as you see, we cannot establish directly the connection because we need to first column map between the Excel file and our tool. Okay, it's very simple. Once prepared the Excel, this is a matter of clicking next, basically. And now we have it highlighted so we can complete the connection. Okay. Okay, we connect to it. So now we are in the tool wrapped. And what we're going to do basically is to select the worksheet that we want to work with. And in this case, we're going to specify the metrics configuration, right? This is going to provide us with the different metrics, the elements that are going to help us to complete this quality assessment throughout the requirement specification or any element verification. Okay. Well, in this case, only requirement specification itself and quality assessment. Okay. So let's continue. This is the window that it's popped up for your authoring of the different requirements. In this case, you will see it again in the RQA tool. But in this case, what we are basically taking a look at is the different sections. And the first one, I don't want it to be unnoticed. So this is going to be authoring without patterns because we have not selected in any of them yet. But in this place is where we are going to actually write the requirement. We continue with the correctness metric summary. In this case, we're going to lively evaluate the quality of the requirement that we are specifying. And now here we have all the quality elements, which basically specifies the different elements involved in the quality metric that we have configured before. Okay. We start specifying the temperature warrior. In this case, shall, as you noticed on the right-hand side, we have the evaluation of the quality as we go through the writing process. Okay. Shall withstand environment temperatures between 22, and here I made a mistake because I wrote and wrong, and then the tool is basically gonna warn me. It's gonna say, okay, there's an incorrect spelling, so you should correct it, right? If I click on it, I can see specifically where my mistake has been made, and I can take a look at the different information regarding that metric. Okay, so we will correct that. Perfect. And now if you notice, the low quality remains there, but it is not because of the same mistake, right? We have now accuracy, ensure numbers are followed by units or noun qualifications, which is something we talked about before. We have always to include the measurement unit with the number. Okay, we'll take a look at that example, that correction on the next clip. Okay, so we save the requirement itself. Now we're going to proceed with creating a few other ones. So this regards to the power system, which is a subsystem within the overall temperature warrior. Shall produce an output voltage. There's no problem there, but here we have the issue, right? We have made a mistake in terms of the measurement unit. We have expressed voltage as kilometers, which is not acceptable, of course, right? So we're going to be noticed with it. Sorry. Here, detect inadequate unit for a characteristic. In this case, as we were mentioning, voltage and kilometers. So continuing with this specification, now we will take a look at another example. So this is basically going to consist on terms of what we talked about before. Accuracy, trying to keep things short and precise. In this case, what we have clearly is a matter of multiple subjects. We have the temperature registration system and the control system, specifying the weight that each one has to have. And of course, this is wrong. We should try to break this requirement apart and specify two different ones with each of the weights. Okay, which is what we are doing now. We take out the part of the control system. We can simply select save and continue. Here we paste the control system and we proceed to including the weight corresponding to this subsystem. Okay, so no problem there. We have corrected that issue also. and we continue. For the next one, what we are basically going to do is specify something that in terms of correctness is going to be right, but in terms of consistency, it is, of course, so as you can notice here, we have high quality in terms of correctness, but we have specified the temperature warrior shall weigh less than 110 lepts. In this case, of course, weight is being measured previously on kilograms, sorry, and now we're using a different metric unit. So there's something which concerns consistency. We'll take a look at it more detail later. So for this case, this is, I think it's a final one. The temperature warrior shall have a management system, and in addition, it shall have a temperature actuation system. Okay. So what is the problem here? Of course, we are combining two different requirements into the same one. We have two shalls, and on top of that, we have made a reference. We have used the pronoun it to refer to the temperature warrior, which is a huge mistake. It should be fragmented once again, separated, and specified clearly into different requirements. Okay, which is basically what we are going to do now. So move that part. The second one, save and continue. In this case, we substitute the it for the actual element we are referring to, temperature warrior shall have a temperature actuation system. Okay. So we save and close, and we basically have our specification. Let's imagine this is our specification. We save it, and we conclude for the red part. Okay. So we proceed with the quality analysis. In this case, this is our RQA tool. As you can notice, the connection is already established because the tools are connected between each other. So we only have to connect to it, and that's it. Okay. Now we have to select the worksheet once again. Here we can see that we have all our requirements previously specified. This could be omitted because here what we select is to evaluate the correctness for all the specification. It asks you if you want to proceed with that process. Click yes, and then we start taking a look at the different requirements. So the first one is going to be what we talked about before. The temperature warrior shall withstand environment temperatures between 20 and 22 degrees, right? So we are lacking there a metric unit behind the 20. Notice that in this case, the and is not identified as a problem like in the other cases, okay? In the other case, when we had two shall verbs here, let me take a look at it very quickly, because this is interesting. Okay. Shall wait. Here what we have is multiple subjects, and we have two ands, two different ands, which is basically avoiding the use of combination out of the condition block, right? And why in this case is not identified as avoiding this the use of these combinators out of the condition block? Because it identifies, it knows, the tool is programmed to know which are ands that you do not want to have, because you're combining different elements within the same requirement, which is bad because it goes against the accuracy, the precision, and the shortness of that requirement. And those cases in which you're trying to specify between ranges, so on and so forth, right? So this case is the clarification because due to the fact that the tool is prepared to identify those different scenarios, right? So in this case, we proceed with the example that we talked about before. We have the 20, we have to specify the degrees Celsius. So once we do it, the tool automatically calculates the correctness quality, and we have it completed. We save, and we proceed with the next one, which is basically the one regarding the power system. Okay. So shall produce an output voltage of 200 kilometers. That's wrong because we have voltage in kilometers associated. We should have voltage and those volts. right? So now we're popped up with another problem, which is basically, it tells us to force to include the tolerance, value for the units that require tolerance. Okay, so in this case, we have defined the metrics to specify us or to require us to include that tolerance, and we have not done it initially, right? So you have to do it now. And imagine you are you're specifying the project. You have tried a few simulations, and you determine that 1.5 is more than enough and it's perfect for the tolerance of your project, right? And this quality metric is going to be now changed to ensure that the tolerance values are within an adequate value range. The tool automatically can identify for which characteristics or for which characteristics the tolerance is low or is too high, right? So in this case, let's imagine that for the sake of the example, we want this to be 1.5 and we do not want it to change, right? What we do is basically we'll first reevaluate to see that the correctness is not being modified. Okay, so as you can see, we still have 1 star on the tolerance one. And as we want it to remain as 1.5, what we do is we can go here and we can check which is the most frequent error and which is the least frequent error. In this case, we're interested in which is the most frequent error because we only have, in this case, 1. So we see that there is realism, tolerance. It regards the amount of tolerance that we have included to our voltage. So once we have it identified, imagine we have plenty of those. You can see which is the one that is giving you more issues. We go into the metrics configuration. We can search for the tolerance. And this is the metric that helps to ensure the tolerance value for a unit is set within an adequate value range. And basically what we can do is we can, in this case, disable, but we can enable or disable at will so that this specific metric is not considered when trying to complete the evaluation. So as you will see here in this case, as we reevaluate, the quality is given as 3 stars because that metric is not considered, right? The same can happen otherwise. We can include new metrics if you desire so. And it's very simple. It's simpler than it seems. So here what we have done is basically evaluate for consistency. And we see that the 2 first ones have not any issues, but the 3 last ones have the issue regarding the kilogram, and the, we have it here. So we have 2 different measurement units for the weight. So what we will do is basically correct it to kilograms. We save that, and we now reevaluate the consistency, right? So perfect. We have all as 3 stars, correctness, consistency. We should do the same with completeness, of course, but as this is a basic example, I wanted to just keep it there, right? So thank you very much. I hope that I have clarified or introduced you to the requirements quality assessment. And of course, feel free to raise any discussion, to raise any question that you might have, and we can solve it here, or even after the webinar, as Cecilia explained, mail us or send us a message without any issue.
Thank you very much for the presentation. Jose Manuel will answer your questions in a couple of minutes. So if you want to ask him anything, please write down your questions in the chat box and you can address them to everyone. Meanwhile, I will tell you about our next webinar. Optimization of the requirements engineering process and techniques using the systems engineering suite. Clear requirements are one of the most critical objectives in a successful project, but the process to get there is quite generic and overarching, even though being requested by plenty of standards and good practices. How do you achieve an effective requirements round trip that ensures information correctness, consistency, and completeness? Throughout this webinar, you will be shown some basic techniques that include capturing knowledge, manage quality, interoperability, traceability, and verification and validation, ensuring superior quality and knowledge reuse provided by the different tools in the Systems Engineering Suite. The dates for this webinar are the 15th and 16th of June. So let's see if we have any questions. When having requirements stored in an Excel file, what happens if two persons use RQA and RAT simultaneously on that file?
Okay, so you basically, this is a really good question. And what you basically do is when you're trying to write the requirements on RAT, you can save directly. Imagine a person is operating in RAT tool and another one is operating in RQA. The person who's operating in RAT and is writing the requirements, imagine we are including a new one or we are modifying a specific one. If we're doing so in the RAT tool, what we can do is basically we save, and then the person in the RQA must reload the ontology, and then it should bring all the changes back. Of course, warning about the new updates, right? And if we're talking about the other way, because of course, in this scenario, we have two possibilities. The first one is that RAT updates before or RQA updates before, right? So if RQA updates before, maybe we should, what it happens is that you're trying to evaluate the quality of a specific requirement, or you complete the assessment of a specific requirement. And then if you save and the other person is working, this person working on the RAT tool will be notified that there has been a quality assessment. And therefore, you can decide then if you want to modify and to propagate the changes back, or you want to wait a little bit until the evaluation has been completed, saved everything, and then you can add new requirements and you can continue modifying, right?
Okay, thank you. Next question. The unit shall weigh 4 kilos sounds to me a requirement of poor quality. No tolerance. It specifies a precise weight. That is, the unit cannot weigh less than, but the system does not identify it as a poor quality one. Could you please explain why?
Yes, of course. This is a great question. As the purpose of this webinar is to introduce you to initial or to basic ideas regarding quality assessment. In this case, what we have used for our tool is a white belt. We call it a white belt, like in martial arts, the initial belts, right? So the top one is the black belt, and the lowest one is the white belt. In this case, what we have done is we have used the out-of-the-box database, and we have tweaked it a little bit to make it even simpler for the examples to be very, very basic. But of course, what you have said is true. That requirement concerning the kilograms needs a tolerance also. We need to specify which is the actual weight, and not only saying it is less than. But yeah, for the sake of the example, you can, and this can be applied, of course, to your daily work. You can adjust the belt, the difficulty belt in terms of quality assessment. So how strict you are with your quality assessment, depending on the configuration of your metrics, right? You can add new metrics in the RQA tool, and therefore you will have, you will be more restrictive, right? And you will not let the tool let slip those issues, right? So this is very interesting. You can tailor the tool. You can include new metrics to make these more consistent, more precise, and more strict in terms of ensuring that each one of the elements within the structure that you require for your requirement has been satisfied, right? Of course, here we can get into patterns also, which are great to ensure, as we were mentioning before, the structure of each one of the requirements. And this, of course, should be could be a great example of it. So definitely, in this case, the belt applied is really, really low. So therefore, that's why the tool, the element in this case, or this issue that you mentioned in this case, is going unnoticed. But It wouldn't if we had configured the metrics, the quality metrics, to be stricter, right, or more strict. So thank you for your answer.
Thank you, Jose. So we have no further questions. So thank you very much, everybody, for attending. If you have any additional questions later or want more information about our tools, don't hesitate to contact us by email to contact@reusecompany.com or through our website, reusecompany.com. Thank you very much and goodbye.
Thank you very much.